what we had up until now were variables and then sentences that all evaluated to true and false. And now we're going to expand our universe to having a set of objects, right? And those objects could be people, or they could be integers, or they could be real numbers. Who knows what they are, right? And then we're going to have predicates. So a predicate takes on one object and it tells you whether or not that object has this property, right? So boy, what it does is it takes on an object and it returns a Boolean, right? And the nice thing about that is we already know how to do Booleans, right? So we're going to take boys, right? Boy X, if X happens to be a boy, then this will be true. And if X is not a father, then that will be false. And then we can say boy X or father X, right? Because we can build up predicates like statements as we did before. Then we can have other sort of things. We can call it a relation when it has two objects or maybe more objects, because it's telling you the relationship between them, right? If I often talk about boy B loves girl G, then this relationship is true. All right, and right there, I actually did something which is against formal logic, because in formal logic, each variable takes on any object from the universe, right? Well, I kind of was heterosexual there, which I apologize for, binary sexes, and assumed B was a boy and G was a girl, but really they could be anybody. Right? And then you can build up. So this is kind of, if you want to, so what's happening here is if I talk about a general universe, then I don't know what the objects are, and I don't know how the relations evaluate, right? But if I want to specify a specific universe, then I might say outside of the logic, this isn't in the logic, right? Whenever we have the three batches, that's sort of a definition or an equivalence outside of the logic, which is saying we're defining a father to mean X is the father of Y, right? And then we can go on further and say X is a father if there's somebody he's a father of, right? And then here we can talk about the daughter relation, right? Everybody kind of following this? So this is just here to motivate this. Well, I kind of motivated already to talk about fathers and daughters, right? If I was just writing Forall and exist, you might think it was dumb, right? But let's talk about the sort of things that we can say, right? All we're going to add here is Forall and exist, right? We're still not adding maybes or other weird things you might want, only adding Forall and exist. And from that, you can write down a statement in math that says anything you want, right? And so I have a little brother, I go like this, but he's actually big, who was taking a graduate course in set theory at U of T. So it was a little hard, right? And he was stuck on the problem. And I said, well, let's write down what you know in first order logic. That's this Forall this stuff, right? And then let's write down what you want to know, prove. And then let's play the game like I'm about to teach you. And his solution to his homework assignment just fell out. I mean, it's really, I'm not claiming that when you're doing your PhD, all your problems will fall out. But anything that's set up to be a homework assignment, that level of difficulty will fall out, right? And we'll also sort of show when they don't fall out, what goes wrong. But you can say anything in math. And so, as I said, the proof can just sometimes mechanically fall out. All right, so here's just a little example. All right. Sometimes we let the universe be general, where we don't know what the universe is, and we want it to be true in all universes. And sometimes we tell you what the universe is. All right, so here I'm telling you that the universe is the objects are the integers, actually the positive integers, 0, 1, 2, 3, and we're going to have, we haven't talked about relation, what are they called? Like flux. What is flux? It's an operator, right? What does it do? You have to define it. And here, since we're living over the integers, flux is going to be defined like you know flux to be. It takes two objects, 2 and 3, and it returns 5, right? And we're going to define times normal, right? So here we're going to say that's the universe we're living in. I'm telling you what plus and times and equals. You always get equals in logic, right? So here's actually one little trick. Plus, if you just see it, it might not be what you need it to be. But equals is always, I have 2 objects and they're the same. All right? All right, so now I want to be able to express things using Forall and exist. Right? And so let J be a Java program, and I be an input to that Java program, and Y be a possible output. And then I want to say using Forall and exist, Java program J on input I, outputs Y, right? Now, one thing that is confusing about that is we're working over the integers. So Java programs don't exist, right? So we have to have an encoding where you take every Java program and you think about it written in ASCII, and then you take that whole ASCII and you turn it into one big integer, right? So we're saying the integer, if you plug in here, we want to define a relationship called compute, where if you plug in the integer representing a Java program and you plug in an integer representing an input and an output, this will be a true statement if and only if this is what the Java program does, right? So you might say, okay, who cares? You just write it in English. No, you got to write it in math, right? So within this Forall statement is saying how to compile the Java program into something that works. In fact, what we do is, what I do is compile it into a Turing machine and then show that the Turing machine, and then write down that the Turing machine accepts, right? Why? Because there exists a computation that for every time step it's doing the right thing, right? So you can say amazing things like this. And hence you can write down the halting problem, right? Here's the statement, does J halt on I, right? You guys might not have taken 2001, but let me tell you, there's no algorithm that solves the halting problem, right? It's uncomputable, all right? So why is this bad news? Well, if I can write down a sentence that says this Java program halts, and knowing whether it halts is undecidable, meaning there's no algorithm for it, then it follows that it's undecidable when I give you just a Forall exist statement over the integers, and I want to know is it true over the integers or not, right? There's no algorithm that does that. And then Gödel goes on to prove the incompleteness theorem, which says there's no proof system that proves everything that's true, right? Why? Because if there was a proof system, then you could enumerate all possible proofs and in finite time decide whether it's true or not, right? So just what I'm saying here, there's a lot of crazy mathematics going on, right? That happened with Gödel and Turing in kind of 40s, 50s. All right. Oh dear. Sorry, world. I can hole in the wall. Witnessed it. It was there already, exactly. All right, everybody good? Except for the wall. Sorry, wall. All right. Those are slides just to frighten you. All right? And we're not going to be doing frightening things like that until if we have time for it at the end of the course. All right? Now we're going to do simpler things, but I just wanted you to, it's always good to know that the simple things you do aren't really simple if you go to the extremes. Yeah.
So for like writing logic, are you able to use more than one variable, or do you have to use one variable?
Oh, we already did. X loves Y, B loves G. So yes, you got lots of variables. And all right. So if we're going to be heteronormative, we can say boy loves girl, and then you have to say in what universe does which boy, right? So here is one way to find a universe. I can tell you that I have these boys and these girls, and I put an edge between them if the boy in question loves the girl in question, right? So then, oh, here's another way of saying the same thing, right? It becomes a truth table. Here, red boy loves Marilyn Monroe, and red boy loves Marilyn Monroe is true, right? People see that? All right, so sorry for the heteronormativeness of it. So here, in this universe, Sam loves Mary happens to be false, right? And people sometimes panic. How do I know whether it's going to be true or not on the test? Well, either we're going to be doing one of two things. Either we're going to be asking, is it true in every universe? And obviously, this is not the case in every universe. In some universes, Sam is a potato, and he loves whatever that means, Mary, who's a flower, right? I mean, different universes are different things. So if you can ask, is it true in every universe, which makes it valid, and that's what valid means, is it's true in every universe. And here it's not clearly. So if I want to know if it's true, I'm talking about a specific universe, right? So I'd have to tell you the universe, right? And here Sam does love Beth, right? And what if you don't know these symbols, learn them right now, right? Backwards E is exists, and for all has an A in it. It's an upside down A, all right? So if we want to say there exists the boy that loves Mary, then we say there exists the boy that boy loves Mary, right? Holler if you're not getting this. And that's here, where is Mary? Here's Mary up there. It's false that there exists the boy that loves Mary in this universe, right? There exists the boy that loves Beth. Yeah, right? How would I prove that? I would prove that by saying, look at Bob loves Beth, right? We don't have to do any formal proof. We can just sort of say, hey, I want to prove there exists the boy that has a property. I construct that boy, and I show you that boy has the property, right? All boys love Beth. right? We say for every boy B loves Beth. Is that true? No, John doesn't love Beth, right? Proof by contradiction. All boys love Marilyn Monroe. Yeah, I think, oh, no, that isn't true, maybe. Oh, Marilyn Monroe. Doesn't love Bob. All right, so, hey, maybe I should fix this slide. Everybody loves Marilyn Monroe, right?